Let's see, desktop 2. Oh, no, what happened? Cool, can you guys see my screen?
Yeah.
All right, cool. So yeah, I saw a little quick announcement. I saw April and Austin, they're dressed real fresh. I was about to do my presentation in a robe, so I'm glad I saw their outfit wear. Otherwise, I would have looked like a bum. But yeah, good morning, everyone, and welcome to my tech talk. I'll be giving you guys a quick and high-level overview of TypeScript. Hopefully, you guys don't fall asleep. So to begin, I'll go over a little bit of the history of TypeScript. So Microsoft, under the Apache 2 license, if I'm pronouncing that correct, developed the TypeScript and also maintained under it. Then we have Anders Hedge, blah, 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 can't even try pronouncing that, who developed TypeScript. It was first introduced to the public on October 1st, 2012. Then Microsoft released a new version of TypeScript 0.9 in 2013 after 2 years of internal development. I believe the current version is TypeScript 3.8, which was developed February 20th, 2020. So this version includes changes to the compiler, performance, and the editor. Oops. All right, so what exactly is TypeScript? For those of you that are familiar with how fast it's like CSS, we can basically say TypeScript is to JavaScript. So TypeScript is pretty much a superset of JavaScript, meaning all valid JavaScript code is valid TypeScript code. So TypeScript has pretty much all the functionality that JavaScript has. So you guys can still use your built-in methods, .map, .filter, .include, .index of. So if you guys did a lot of the whiteboarding challenges, I'm pretty sure you're familiar with those. I would say TypeScript is almost a better version of JavaScript, but we have to keep in mind that TypeScript is a programming language, but also a tool. So it's a powerful compiler which you run over your code to compile your TypeScript code to JavaScript. And one of the main advantages of TypeScript is it allows users to use strict typing. So everything stays the way that we define it. So let's say we need a variable to always be a number, then it'll always be a number if we declare it that way. And I'll show you guys later down the line how this is done. I think it's like 2 slides down. So pretty much JavaScript versus TypeScript. So as many of you know, JavaScript is a dynamically typed language. It basically has no types. So it's a little hard to control, like all the parameters and the variables when it comes to like using them and validating them. But there's a good possibility to make mistakes in your code, like forgetting to declare a variable or calling a non-existent function or passing like a parameter, a variable that will end up breaking your code physically, or I think it's even worse is logically. That's when you really need to start thinking. So we can say that TypeScript is like JavaScript, but with types. It helps make our code easier to read and avoid errors that can possibly be difficult to fix in the long run, especially when we're like 50 lines, 100 lines deep in our code. So pretty much JavaScript uses a .js extension. So if you're using an editor like Atom or VS Code, you would pretty much just name your file and end it with .js. TypeScript uses the .ts extension. So when you do run a command, you do like tsc on whatever TS file you're working with, and it will generate a compiled JavaScript version of that code. And I'll show you guys that in the next slide. So here we have a very simple and basic example to display one of the advantages of TypeScript. So in our example here, we have our JavaScript file. I've created a basic add function. So it takes in 2 arguments and returns us the added value of the 2. In this example, we have 1 and 2, which we would want a result of 3, but we're actually returning a value of 12 instead. Why is that? Well, here we have the number 1 and a string of the number 2, which ends up in concatenation, hence giving us the 12. And this is where TypeScript actually comes into play, because right now for add function, I think we'd want to receive a result of 3. So we want to accept pretty much just numbers, not strings. We don't want booleans or any other data type, pretty much just numbers. And give me 1 second. So if we look at the TypeScript example here, you'll see I added a colon here and specified the type, which is number. So this would be considered an explicit type, which are used in our TypeScript files, not the JavaScript files, but in TypeScript. So this would be considered like TypeScript syntax. So when we run this code, we actually use a command. If you kind of look at the bottom, I didn't add any arrows or anything like that. But if you look at the bottom, it says like tsc example-ts.ts. What happens is it'll actually compile to JavaScript and generate a example-ts.javascript file, which I'm actually not going to dive into. I'm going to keep it more basic. But the cool thing is, for those of you that don't know, if you hit command backtick, it will give us the terminal in whatever IDE you're using. Yeah, below the terminal, we're actually given an error. So you'll kind of see we have argument of type 2 is not assignable to a parameter of type number, which I think is pretty cool because TypeScript forces us to write better, cleaner, and less error-prone code. And it will give us the error before runtime. So you see with the red squiggly lines, we have the 2 underline. So if we actually scroll over that, which I can't with my mouse, it'll kind of give us an error, letting us know what's wrong with it. So we can actually fix it before we even run it. Oops. All right. So some advantages of TypeScript. So kind of to reiterate some of the advantages we do have. So it's browser compatibility. So TypeScript compiler does some workarounds to transform your code and make it compatible with all modern browsers. So in other words, by default, the code that the TypeScript compiler spits out is ES5 compliant, and a lot of modern browsers understand the ES5 of JavaScript. Then another cool thing about TypeScript is that we can use the latest JavaScript features on our code. So not all modern browsers understand that the code if we use the latest feature, like let's say ES8 or something. We usually need to use additional tools to make that possible. But if we use TypeScript, the compiler is going to do all the hard work and get everything working for us. Since TypeScript is a package, we can install it in our project using npm node package manager. If we keep the version update, we'll automatically have all the new stuff available, like ES6, 7, 8, whatever the latest version is. Then a really good advantage of TypeScript is its code completion and IntelliSense. So IntelliSense provides active hints when the code is added. So like you did scroll over that squiggly line 2, then you'd see like what the error was. Then TypeScript does provide static typing through type annotation. So to enable type checking at compile time. So the cool thing is this is optional and can be ignored to just use like the regular functionality of dynamic typing of JavaScript. But yeah, basically sums up my presentation. So if you guys want to start experimenting with TypeScript, you can actually run this command on your terminal and just remember to use like the extension .ts to start working with TypeScript. Other than that, do any of you guys have any questions?
Is there a Yarn add install?
I believe so, yes. Any other questions? If not,
Aaron, why did you pick this topic? Like, what made you interested in TypeScript?
So I chose this topic because the company I'm going to be interning with uses TypeScript, and I'm actually pretty happy because I feel like JavaScript is one of my stronger suits. So I'm glad that we're going to be working with that. Plus, it's pretty much JavaScript just with wings. So yeah, I'm liking it so far. And I'll stop sharing. Any other questions?
Aaron, what would you say to someone who says, or I guess my question is, do you feel that you need to know JavaScript before diving into TypeScript, or could you just start learning TypeScript rather than JavaScript?
I would recommend having a pretty solid foundation of JavaScript before jumping into TypeScript. I mean, pretty much it has all of the same functionality. So I guess you can start off with TypeScript, but I think in the long run, it'd be better to actually work with JavaScript first. Yeah, if there's no other questions, I'll hand it over to the next presenter if I can find my stop share. Yeah, thank you guys.
Nice job. Thank you, Aaron. That was great. Ara.
All right, let me share my screen. Can you guys see my screen? Okay, how about here, present. Do you guys see this? Okay, good. So I didn't know how to change this picture, so it's there, but nothing related to my tech talks. So my name is Ara. I will be giving you tech talks today about asynchronous salary, why and how. So let's start from the first. Okay. Oh, that's not how I want it. Oh no. How about this? Okay, here. So you probably experienced looking at a blank screen screen page while waiting for something show up, right? But have you wondered actually what is happening in your browser? So today I'll be talking about some possibilities that what might be happening when you encounter this kind of situation on your browser on the server side, and what are the ways that you could improve the user experience. So first, CRUD, which stands for create, read, update, and delete, and login and log out, it's an important part of the HTTP request cycle. And the best practice is that when the client asks or requests server, the server should give client immediate response. So if that doesn't happen, that's where user will have to, staring at this blank page, something to show up and waiting. So we know that it's not a very good user experience. So now our app might start with simple CRUD, but there's more functions that we want our users to interact with, such as sending maybe confirmation email to the user or activity emails to the users, or daily scraping some information from different sources and storing them in a database, or exporting documents or photos in various formats. So those are the background tasks that is like normal, outside of the normal HTTP request cycle. Now, how do you define the background task? So they're not essential for the basic functionality of the web app, but they can't really run in the regular request response cycle because they're slow. If you remember the staring at the blanking page. And it has to be executed on a schedule. Like when you register in the new website, you get maybe confirmation email, right? Like welcome email. Or when you forget your password, you get like password reset email. So those things that we're gonna define as a background task. So now I'm gonna give you actual situations. So you have your web apps and you want the user to do something. Good. So you write some code that does for them. However, that something involves fetching the top 50 images of cats from a Google, Facebook, Twitter, whatever you name it, all the image research. So you know that it's gonna take at the best, it's take a few seconds, it could take a minute. So you might try as a solution. As a first option would be you are directly fetching more things on the request. So this code is actually written in Python, so you don't have to worry about too much of the code, but basically you want the view shows after downloading lots of cat images and then give it back to the user, which would take longer. And the side effect of this, just fetching more things under one request, would be like user sits there waiting for the screen to show up, and they probably start thinking, why isn't loading? Did I something do wrong? Did I break it? It's like worst case, user just leaves, right? So we don't want that situation. So we can improve by using two different requests. So instead of the same request, one would be purely for returning the page, and then another one would be the fetching the cat. Not a bad solution, to be honest. This solution would work for a lot of situations. And another thing for this is that you could still give the user feedback by maybe showing the loading page, hey, it's still loading. So the user knows that, oh, okay, I didn't break anything. It's not broke. It is still loading. Gotcha. I wait for you until you're done. So this situation is pretty good, but there's a limitation, is that the page is still waiting until the fetching part is done, which is still kind of, it's not really valuable to combine those two. So now, today, my subject that I'm proud to present, the celery, and it actually has a celery logo. It's a built-in library in Python. So basically you can take the fetching part or anything that is not a regular normal cycle, you can take out of the process and then give the text to the celery through the broker. So in this here broker, you can just think as like a queue where lines of the, or task in line waiting to be done, right? And then the celery checks, hey, is there any test to be done? And then broker passes the test to the celery, and then the task seller will process the task. So I will show you a quick demo, but first I just wanted to show you how this async library celery works. So basically the normal HTTP cycle is running while you do background task. So user can do anything they want without, you know, that waiting their parts. So it's pretty useful. So how hard is to write? Again, this is Python, but I'll give you like 3 seconds to see what is the difference between first function and second function. The only difference, I'm sure you have noticed, so I'm just gonna move on because I don't have time. So here, I just added the task, the decorator to the function. So when you actually call the function, instead of calling download lots of cat images, you just put the dot delay. Because this dot delay, it indicates that, hey, celery, this is a task for you to execute. So I have like a small screenshot. When you see the async result, you're not seeing what you expected. Like in this case, it should be 8, but you kind of have to look it up, specific ID to see the result. But I just wanted to show you what is the syntax looks like. Now, I want to give you actually a real demo. So before that, if you look at it, this is a broker where there's a lot of tasks to be done. And then this broker send the task to the celery to work. So this broker, there's some tools that you have to use. They could be any other two, but RabbitMQ and Redis, they're most popular. So I'd like to show you the actual part of my code. So here, can you guys see this screen, my code? Good. So this is the code. So I create a function, send some mail. So I imported the celery here, and I'm running the broker, my broker. I'm using RabbitMQ in this case. And I also imported a library where it allows me to send email. So I'm actually sending email from myself to myself. Yeah, so just one thing is that I'm running the celery and I'm running Python shell to call the function. And I'm also running the broker, RabbitMQ. So you have to make sure that everything is running. If you want to know the command, I can send you, I can put it in the chat later. So here, I'm also actually, I also opened the browser called Flower. So when I call the function, you should see this active changing to 1. And when it's done, it will change to 7. I mean, I already tested like 6 times. So it's done, but you will see the changes. So pay attention to that. So I'm gonna import send some email from this test celery, the function. And then I'm actually do that, done with. So I'm calling the function using the dot delay where it's gonna now the seller is gonna understand, okay, it's a task to be done. And then it will send the email to this address with this message. The work is done with the celery. So I'm gonna hit the enter. So as you see, this result, it's not what you expected to see, but here, now it's active is 1. When it's done, it should change to 7, which it did. So that means it succeeded it. So here, on the top, it ran in 7 seconds. So that's the recent email that I sent. And if you look at it here, the email has sent. The work is done with celery. So it's really cool because, again, all the background tests doesn't have to interrupt user experience. So yeah, I think that was for my demo. Right. Okay, here. So these are the resources that I use if you're interested in Celery setup. Oh, by the way, Ruby has something similar. It's called Sidekick. So if you want to look it up, so I think Sidekick does this background task too, like Celery. And sending emails with Python and all the articles that I look at. Do you have any question? I'm done. I had to go through quick. What?
Why is it called celery?
I don't know, to be honest. I mean, their logo is like a celery vegetable. Maybe it's like a connecting. I don't know. Good question.
All right, is the celery thing something you're using in your internship, or like what drew you to looking at this particular piece?
So like I was always wondering when the page loads, like maybe taking a while, or like getting confirmation emails and stuff like that. This is something that we probably have to implement to make user experience like better. So I was like researching, and it was just like a really interesting topic, and I thought that you guys can also use in your job, because this is a really great library, and also there's available in Ruby that it will like, it just like takes your app different level, like, you know, for the user too. So that's why. All right, I'll stop sharing. Thank you. Oh, sorry, I didn't read the chat. Oh, okay. All right. Yeah.
Aura, can you share with us what platform you used for your presentation?
Oh, Prezi. I use Prezi. So I use it for when I started teaching too, and it has some animations, so I liked it. Yeah. So if you guys want to use it, let me put it in the chat.
Cool.
And what was the when you showed us where like all of the things were logging and processing, what was that part?
Flower. It's called Flower.
Flower? Okay.
But maybe just put like a Flower Django or Flower Python, something like that.
That's
Yeah.
cool. I like that user interface.
Yeah, it's really great. All right, thank you guys for paying attention. I hope I didn't bore you.
Thanks, Ara. Great job. That was awesome. All righty. Nikki.
Okay. Okay, can everyone see? Hello?
You're
Yep.
Yeah,
Oh, can you see the bright pink page?
Yes.
Okay, cool. Okay, so I'm Nikki. I'm gonna be doing a tech talk on Sass. So what is Sass? Sass stands for Syntactically Awesome Style Sheet. It was created in 2006 as a feature of the Haml markup language. It's basically just an extension of CSS. People like to refer to Sass as CSS with superpowers. It allows you to go beyond the natural capabilities of CSS using a lot more features, allowing it to act more like a programming language. So the browser doesn't read Sass, so you need to compile it down to CSS. And it's pretty easy. There's a bunch of different ways to do it. I listed some of them here. You could use Yarn or NPM, but my favorite is if you have VS Code, there's just an extension you can use, Live Sass Compiler, and you can do it that way. So why would you use Sass? Well, it's easy to adapt to. Sass uses features that are similar to other programming languages. So if you know JavaScript or CSS, Ruby, you could use it super easy. Sass keeps your code super organized, allows you to write faster, more efficient code, and it dries up your code a substantial amount too, keeping it nice and clean and manageable. and you're not going to be looking at that huge, long, drawn out CSS page. And it's fun. Who doesn't like to learn new things? So Sass takes in 2 different types of syntaxes. The SASS, which is the one they started out with, and it uses the .sass file extension, and that uses indentation. It doesn't use the curly braces or semicolons you're used to in CSS. But if you want to take a look, see, voila. And then later on came the SCSS file extension, stands for Sassy CSS. And it's just like CSS syntax. So all valid CSS is valid SCSS. This is the most popular. People gravitate towards this more because they're already used to using CSS. And just like you'd expect, it looks just like that. So I'm going to name some of the features of CSS, not all of them, but let's check out those super cool features. Variables. So just like in other programming languages, Sass allows the use of variables. You can put CSS values in them and reuse them throughout your code. They're prefixed with a $, and then the variable name, and then the CSS declaration. They're super big time savers. Say you had like 10 buttons for some reason, and they're all blue, and you wanted to change those buttons. So rather than going line by line and changing them, you could just do it in the one variable spot. And next is mixins and functions. They're pretty similar to each other. They both take in blocks of code and produce an outcome that you can later call in your code. The difference is that functions compute values and return them, whereas mixins just define CSS values. In my examples here, I'm just going to be using mixins for it. So this example right here, sorry, I remembered my portfolio. So I remembered I had to use these 3 lines of code over and over and over again just to center something. So rather than doing this over and over again, I would just throw it in a mixin and then call that mixin wherever I wanted to. This dries up your code a lot. Next, you can also give mixins an argument. So you can pass in custom values to make the mixins more powerful and dynamic. So with this mixin, I'm going to give a border radius to different things through the use of a mixin and an argument. So you give the mixin a name and then an argument. And then within the block of code, you use a selector, which is the border radius. And then these are just all the vendor prefixes that go along with it for the different browsers. But then you pass in the argument to that as well. And then when you want to include this in your code, you would just call it, and then you'd pass in that argument. So you do 5px. If you had a different button, you wanted it to be rounder, you would pass in a different value of like 20px or something. But this saves and dries up your code a lot, so you don't have to reuse this over and over and over again. Next is nesting. Allows you to nest your properties, and CSS doesn't. So rather than having like your parent and your child and the parent and the child and the parent and the child, you would just simply nest them with all the children selectors inside of the nav bar, inside of the nav. Classic. But this keeps you more organized, and I think I would use this. It just looks nicer. Next is my favorite is partials. So basically it's just splitting up one large Sass file into smaller Sass files. It's similar to React components. It's like the exact same. So if you know React, it's just like that. This allows you to take like smaller Sass files, take one large Sass file and put it into smaller Sass files. This is going to keep you more organized, allow for easier navigation, and allows you to code faster. And I think it'd be super helpful if you were working with a partner and they wanted to, change the style of something, and they're not looking at this one large CSS style sheet. they could just find the partial that they need to use. But oh yeah, so this is how you use them. You use underscore and then the file and then the partial name and then the file extension. And then you import it into the main CSS file with the import and then the file path. But I'm pretty much out of time, so I decided to just show you all the other features here. You can, like other languages, you could use conditionals, loops, operators. Maps isn't what you think. It's not like the map function. This is like, it holds key value pairs and makes you look. It makes it easy to look up a value by its corresponding key. And inheritance is super similar to mixins. Extends properties from one selector to another. And that's it. Thank you. Any questions?
Yeah, I have a question.
Yeah.
For the functions that you just showed on the very last page, can you explain like what for what they would do? So is it meaning like, for example, the @while, that's saying that like while a certain function in your main code is running, it's going to apply a certain CSS only during that time or something, or what's how's that work?
It's for looping. So the loops. It's just similar to like JavaScript loops. You have that for loop, the while loop, and the each loop. I'm not sure. I'd have to look into that one more, but just looping.
Cool, thank you.
Yeah. Any other questions?
Are you going to refactor all your CSS to Sass now?
I'm going to try for sure. Yeah, it's super easy. It's the same syntax, so you just definitely.
Nikki, what are the benefits of drying up your code?
So it's a lot easier to look at, when you dry things up. It keeps you more organized too. Yeah, I'm not.
Cool.
Nikki, what made you want to do this talk versus the other talks?
Well, because they made us, Sarah and them put Sass in one of our projects, and I didn't know much about it, so I wanted to explore it more.
You mentioned using this in your portfolio, or were you referencing a different style?
So I didn't use this in my portfolio, but I'm gonna use it in my portfolio for sure. Because I remember looking at my CSS style sheet in my portfolio being like, what is going on here? So I feel like if I implement this and make it look a lot nicer.
Nice work, Nikki.
Thank you.
Awesome. All righty. It's been so great. Austin, you are up next.
All right. Let's make sure I got everything going. And also real quick, big ups to Nikki. That was great. You solved a problem for me on my portfolio where I had that theme changer, and I'm going to go back and refactor it to actually having nested elements. That way I don't have copies of everything going on. So that was really, really helpful. So as far as I can tell, we're actually ahead on time. So I might take a little bit of that extra time if that's okay with everyone else. I'm not going to take too much, but today I'm going to be talking about augmented reality. This turned into a much bigger topic than I was expecting. And I don't think it would be a good augmented reality talk unless there was some interaction between myself and you guys. So if you want to go ahead and open up an HTML file, I'm going to be sharing in the 2020B Slack code for the end of the project. And if one of the instructors could please share that with 2020C, I'd really appreciate it. Let's see
You
if I
got
can
it.
find a way. Cool. So welcome to my talk on augmented reality. Again, my name is Austin Walker, and let's get going. So real quick, what is augmented reality? When I was a little kid, I was really obsessed with the Star Wars holograms. I thought holograms were going to be a real thing by the year 2000. I was less than 10 years old. Holograms are actually, interestingly, more real today than you might think they are. So we're going to talk a little bit about that. First is to define some points: augmented reality, virtual reality, mixed reality, and X reality. Augmented reality, and I found this definition by Caitlin Irvin. I really like this definition. I think it's better than Wikipedia. She's a great widget designer and journalist. So check out her stuff if you have a moment. Augmented reality is an overlay of computer-generated information or images or whatever on top of the real world. One of the early prototypes for this was the heads-up display. We'll talk a little bit about that in the next slide. But you can also think of things like interactive projections on Disneyland rides, and probably the most ubiquitous augmented reality form is the Snapchat Lens, the face filtered face changer. You may not even think about it as augmented reality, and I didn't until I did this talk. Next up is mixed reality. Mixed reality includes spatial computing, some diagnostic equipment for the medical field, some surgical robots that can understand what's going on while they're being moved and controlled. Drone piloting, and then especially persistent geolocated objects like, say, a game objective that exists in the real world that you can go and interact with, and persists when you're not interacting with it. Third is virtual reality, something we're probably all familiar with. It kind of uses a catch-all term, and so is the next term, X reality. But virtual reality has a specific aspect of it's only virtual reality completely and without anything else when you're fully immersed in a computer-generated dimension that has no bearing on the external world. It has nothing impacts it from the external world, say, other than the physical processing units. And then finally is X reality or extended reality. This refers to all real and virtual environments generated by computer technology and wearables. It's honestly just a catch-all term for everything. This could even include, and I would say includes, Tupac performing at Coachella in 2012 post-mortem. So how do we get here? The first AR, if you really want to call it that, is something called a strike sight. It was developed by the US Navy and the Royal Air Force in 1958. It's just a projection of visual information that a pilot needed on a screen in front of their windscreen. And it was very, very simple, and it just gave information that literally could not be communicated by somebody behind the pilot. After that, we have 1968, Ivan Sutherland develops the first head-mounted display system, which is the first VR system. Augmented reality is coined in 1990 by Tom Caudell, an engineer at Boeing. Not listed here, I have a few things. In 1992, a guy named Louis Rosenberg develops the first fixture of a system that allows a soldier to guide to virtually guide a machine in the real world. So this is probably your first example of mixed reality. 1998, the first and 10-line computer system is broadcast by SportsVision, which shows the line of scrimmage in football that players are not impacted by. Actually, really confuses a lot of people. It's pretty interesting. That's a fun moment in history. In 2000, for our purposes today, we're going to be talking about web AR. Hirokazu Kato creates the first AR toolkit. It's an open source software library that allows video tracking to overlay graphics on a video camera. 2014, Google Glasses are shipped, and we all kind of know how that went, kind of fizzled out right as it started. And then 2016, Niantic released Pokemon Go to great acclaim, which is another version of AR that we're probably all familiar with. And back in 2015, Snapchat released that lens filter that I was talking about a second ago. So some local San Diego AR companies, in case if you want to look them up, there's a group called Nanobot. They're out in Poway. There's Valtech out in Sorrento Valley. Innovate Mobile is downtown. It's actually kind of close to Learn Academy. Victorize in Carlsbad, whom Nikki and I have the pleasure of working with on Monday as an internship. Big ups to Brian. And Extality is in Encinitas. That's just like 5. That's not even that, or 6. I can count. There's so many AR groups here in San Diego, and I had the privilege of talking to a buddy of mine who's a senior developer for an AR company called Thea Interactive. Some current AR web technologies are A-Frame, ARJS, Amazon's Sumerian for AWS systems, AWS, AR Core, EasyAR, XR, and then also 3, THREE, all capital, is a big one. I just don't have it listed here. AR works on 2 main registration concepts. First is geometric registration. It allows the positioning of the virtual environment onto the actual environment. It uses a geometric marker, or it creates a geometric marker, your AR system will, in order to do this. In that way, it can set the AR on top of the real object. And then photometric registration sets the appearance of the object to match the actual environment. This could be an issue of size, distance, color, or a number of other specified attributes that it's pulling in. This is especially required with 3D models. An honorable mention would be SLAM, not listed here, simultaneous localization and mapping. It's actually becoming much more popular. It's a technology that understands the physical world through feature points. And if you want to know more about that, please ask me later. I just mentioned markers. A marker is something that anchors the AR to the real world. In the middle of the screen, we actually have this marker Hero, which if you guys want to code along with me, we'll be using. So either capture that or pull it from Slack. My first experience with direct marker AR was the Esquire magazine with Tony Stark, or Robert Downey Jr. on it, in which he jumped out of the page at you. It was pretty fun. And another marker could be just a color code, like this cyan, magenta, yellow code. The problem with color codes is that they're really dependent on lighting. And then finally, you can have a geolocation marker like you would experience with Pokemon Go. So with a couple of minutes left, I want to build out an AR app together. If you want, you can just scan this QR code and it'll take you to the GitHub where I have this information. So hopefully there's been enough places you can grab this. First, with our code, we're going to call upon just a couple of scripts. A-Frame, the A-Frame library is going to be where we set up everything. And then we're going to be calling upon this one build out by Jerome Tierney, who's the 8th most prolific GitHub user. He's pretty cool. He hasn't published anything on like Twitter or LinkedIn or anything like that in about a year, but he is constantly updating the ARJS web library. Which is a very simple HTML page. It's going to be completely covered in our camera system. And we're going to embed it with the ARJS using our preset marker Hero. You could see that marker had the word Hero in it earlier. Something that's interesting here is that the scene is a global root, A-scene is a global root object for all A-Frame, ARJS, and 3. It's used in all, in the HTML for all 3 of those. And it inherits from the entity class when you call it in the script above. And then we're adding something called our entity. This is going to be the AR object that we are building, and how big it's positioned. The -1 in position sets it right on top of our AR marker, and the scale is going to be 0.05 on X, Y, and Z axes. You'll see what that looks like here in a second. And then we're just going to finish everything out. So I hope some of you at least have had the time to get this set up. Just open it in your default browser, and it should look a little something like this. And there you have it, our little dinosaur that we brought back to life. So feel free to build that after the talk or when other people aren't giving their presentations today as well. And I'm going to close this, and I'm going to open up another tab real quick. Give me 1 second. Any questions?
Hey, Austin, I have a question. So when you were demoing the dinosaur, I noticed on your camera that when you moved out of a plane, the dinosaur disappeared. Are you able to kind of explain how that is impacted by the AR or the code that you were creating? So I guess what limitations would cause something like that to happen?
So that's a good example of the geometric registration. So because the computer recognizes this object specifically with its dimensions, when it gets to a plane where it can't recognize it anymore, it calls off the script of running the AR system. So it's always going to be looking for that object. I could place that object up on the wall behind me, and it would call the object in relationship to the size of the object in the screen too, which is kind of interesting.
Got it.
The limitations on that are one of the main issues in the AR field of what do we set up as a marker, how accessible is it by other people, which is actually why the AR field is mostly, or I should say the XR field is mostly moving away from markers entirely like this and trying to get better geolocation markers. So Niantic, the Pokemon company, they are literally trying to scan the whole world. So, and whenever you're playing their game, it's also scanning and pinging that information up every 5 seconds. Whenever like you're in the AR plus mode, and they're literally taking those scans so that they have accurate markers placed throughout the world so they can create very specific geolocation events. I thought that was pretty cool. And
do they as a company think, are they making that an open source, I guess we'll call it an API or a data source?
No, that is very much proprietary for them. There's a
so that's why like the Harry Potter augmented reality app is really horrible versus the Pokemon, even though it's the same people.
They made it too, right? And I think one of the problems is they actually try to make the Harry Potter app based on those geolocation markers instead of setting up its own, having the program set up its own image-based markers whenever you're playing. That's a whole different conversation about processing power, information that they can call upon, that kind of stuff. So Harry Potter would be more affected by like your connection to the internet versus like Pokemon would be too, because they're actually trying to retrieve that data from you, so they're not going to let you play without it. But you could technically play it offline.
Got it. Cool.
Under some idea of technicality. Is there any jargon I can clear up for anybody? Is there any questions about like where the industry is headed or how it interacts?
I have a question. How long did it take you to set up that demo that you showed at the end there?
So it took me about 4 minutes to code that HTML file. And that was probably the most impressive part about all this for me, was that AR actually took very little time. Big ups to HTML5 for giving you so many accessors. HTML5 can access your webcam, your geolocation, all this kind of stuff, and it does a lot of processing on its own, let alone running the scripts in the HTML file. So that was kind of cool to find out that HTML actually really helped the AR industry push forward. Okay, well, if there's no other questions, that will be my time. Again, my name is Austin. You can contact me through email. You can also just hit me up on Slack anytime you'd like. I have this great name of Walker, Texas Coder. I really like it. I'm really happy that I got that one, that nobody else did. And some of the resources are augment.com. They have this great infographic about the history of augmented reality, and Wikipedia, the ever savior of last minute talks. Also, it's time to donate to Wikipedia again. That's my talk. Thanks, everyone.
Nice job, Austin. So you actually made the HTML code yourself. That wasn't something that you found?
I did find it, but I also played around with it on my own.
I thought that's very cool.
How do I stop sharing this? It will not give me the options to stop sharing.
You got to find the little bar. Sometimes it hides.
There it is.
Very cool. Alrighty. Chantel.
Did I misremember? Is there a break before or after mine?
I'm seeing just after yours.
Cool. So give me 1 second. I have to close up my HTML file, Austin. That's so cool. All right. Here we go. All right, so my name is Chantel. I'm gonna be doing my tech talk today on Dvorak, or the keyboard layout you've never heard of, but think that you might try after this talk. By show of hands, how many people here have heard of Dvorak? Is that hand count go down at all if I remove the Czech composer from that question? Okay, by a couple people. So I'm going to rewind in history a little bit to pre-tech as we know it, to the year 1868. This gentleman, Christopher Latham Scholes, had just secured his patent for his new invention, the typewriter. So Scholes' original typewriter design actually had an alphabetical keyboard, but one of the issues is if two keys next to each other were hit in rapid succession, they would jam. So instead of trying to fix his invention and make it better, he spent a lot of time rearranging the alphabet to prevent two keys next to each other ever being hit. So that ended up leading to what we know as the QWERTY keyboard. So this layout was designed specifically with the typewriter and has continued for the last 150 years and is what we all learned to type on. So really in 1878 is when this got solidified. Scholes had partnered with Remington, the pistol manufacturer, to manufacture his typewriters, which was just after the Civil War, which is an interesting idea. By 1890, there were 100,000 QWERTY-based typewriters across the US. 3 years later, the typewriter cartel was formed. The top 5 typewriter manufacturers joined together to make the Union Typewriter Company, using QWERTY as their standard. And by 1900, there were 100,000 typewriters being sold annually. So that's several million typewriters that were out there at that point. This really solidified QWERTY as technology continued to grow and build. And it wasn't until 1932 that Dr. August Dvorak came on the scene. Dvorak was an educational psychologist and a professor of education at the University of Washington in Seattle. And he started researching a way to rework the keyboard to make it more ergonomic and efficient. His research took in a lot of different aspects. So he looked at the English alphabet and letter frequency, as well as common letter pairings, or digraphs as they're called. Typing had been around for several decades at that point, so he actually studied typists and their finger movements, as well as the physiology of our hands and what movements are easy, what movements are hard. He looked at ways that speed can be improved for typists, and he also extended his research outside of the English language to other languages that use the Roman alphabet, so that way his design could be more globally accepted, which led to his invention of the Dvorak keyboard layout. So it's hard to look at this and be able to take in all the differences, so let me highlight some things. So starting on the home row, which is where, when you started to type, that's where your ASDF is, all your vowels are located under your left hand, which if you look at letter frequency in the English language, the vowels are some of the most used letters in the alphabet because every word contains them. The most commonly used consonants are under your right hand, whereas the least used letters in the alphabet are in the outer corners. To look at them side by side, again, I'll highlight some things. This means because all the vowels and most used consonants are under your fingers from when you get started, 70% of your typing with Dvorak can be done without moving your fingers. Whereas with QWERTY, only 32% of your typing is done without moving your fingers. That means that with Dvorak, you can type over 3,000 words without ever moving your hands. With QWERTY, because there's only the A on the home row, you can only type about 300 words without moving your hands. The top row is easier for your fingers to reach up. QWERTY, you spend more than 50% of your time reaching up to the top row, whereas Dvorak, it's only 22%. The bottom row is the hardest place to reach down. So Dvorak did his best to make that the least used row, and only 8% of typing with Dvorak is on the bottom row. So looking at QWERTY, this means that 69% of your time is spent reaching for letters outside of the scope of your hand. So all of that, they took this keyboard layout and they actually studied what it was like for users to implement it. They went to a high school district with 27,000 students, split them in half, never typed before. The students who were taught Dvorak were able to reach speeds of 40 words per minute in 18 hours of instruction. QWERTY students took 56 hours, so much faster for a new user to pick up. They also took students who had typed previously using QWERTY and retrained them on Dvorak, and it took them 52 hours to match their previous typing speeds. So that's usually faster than 40 words per minute. That's retraining your brain from one method to another. So this all is going great for Dvorak. He has the studies behind it to back it up, but nobody wanted to implement it. The cost of refactoring the millions of typewriters that were out there at that point was cost prohibitive. And if you look at the year, this was right before World War II. So he tried publishing a book to help it gain traction, didn't work, and the book is no longer even in print. World War II broke out, and a friend of his returned from the war missing an arm. Dvorak then took what he'd learned about letter frequency and hand placement and created two different single hand keyboard layouts. So he was the one who invented the left hand keyboard and the right hand keyboard for single hand typists. So he took that accessibility into heart right at the end of World War II. He still could not gain any traction with his research, with his study, with his invention. And in 1975, not that long ago, he passed away a really bitter old man. He is quoted as saying, "I'm tired of trying to do something worthwhile for the human race. They simply don't want to change." So our respect to Dr. August Dvorak. It was 7 years after his death that the American National Standards Institute recognized the Dvorak keyboard officially and added it to their standards. So is it better? This is something that it's been around long enough, people are interested enough, there's more studies who have been done on it. The Dvorak keyboard is endorsed by the Encyclopedia of Parkinson's Disease. They do say that it's easier for people who have limited movement in their hands, type with only one hand or type with one finger or a wand, to use the Dvorak keyboard. Repetitive stress injuries like carpal tunnel are really easy for typist to get if you're typing all day, every day. If you've ever had a long day typing a paper and your hands are just tired, lots of sources say that switching to Dvorak, because it has less finger movement, has helped relieve pain or eliminate pain from repetitive stress injuries caused by typing in QWERTY. And your fingers do move less. So I want everyone to go put their hands on your keyboard and just move your finger from J to U and J to U. The movement from one key to another up is approximately 1 inch. So if you do up and down 6 times, that finger has moved 1 foot, okay? That's a whole foot in measure. If you think about that, Dvorak estimated that an 8-hour typist would travel their fingers between 12 and 20 miles in one day. With Dvorak, because it minimizes the movement, you're only moving your fingers about 1 mile. So, is it faster? This is something a lot of people want to know, is does this keyboard layout actually make you a faster typist? And the answer is not really. The studies show that switching to Dvorak doesn't necessarily make you a faster typer. A truly fast typer is based on their honing of their skills. The top speeds for both QWERTY and Dvorak are in 215 words per minute. So incredibly fast, but even keyboard layouts outside of QWERTY and Dvorak have been able to show a talented typist can reach that type of speed regardless of the layout. It's really about training. So if you're interested in switching, it's really easy because the American National Standards Institute recognizes Dvorak. It's built into every computer that's released now. So you can go into your keyboard settings and switch to Dvorak really simply. I prefer the Dvorak-QWERTY command on my Mac because that keeps my Command C, Command V, those types of commands the same. I don't have to go searching for where those letters are. So that muscle memory can stay the same for ease of access, whereas the letter typing stays the same as long as you're not touching the command key. If there's a really awesome website, learn.dvorak.nl, and right here you can map your QWERTY keyboard to Dvorak. So instead of having to go to your settings, you can just try it out. All of these words are able to be written without moving your fingers, which is, I think, super interesting. There is more. In the early 2000s, the programmer took the Dvorak keyboard and invented the programmer Dvorak keyboard. So he specifically codes in these languages here, so he took that all into account when he was inventing it. If you notice that the letters are all the same as the original Dvorak keyboard, the upper row is where the changes are. Numbers are shifted. Programmers use numbers, but not as frequently as they're using all the symbols. And the symbols are left and right aligned. One more thing I want everyone to do, if you go and drum your fingers on your desk, starting with your pointer finger, that's how this number configuration is supposed to work. So it would be left hand, right hand, right hand to type the numbers that way, which is a more natural movement of your hands than one than the other. The letters in Dvorak are designed that way too. Because all the vowels are under your left hand, it's impossible for you to write anything without switching your hands. It's, if you take one pointer finger and tap it on the desk as fast as you can, and if you take 2 fingers and alternate them, you're gonna get a lot more taps in. So that's part of the thought process behind Dvorak too, is switching your hands as frequently as possible allows for faster movement and more ergonomic movement with your hands. I'm gonna finish it out with a quote from the inventor of the Dvorak programmer keyboard. He said, "It isn't about being faster, it's about being easier. Dvorak keyboards are easier because the most common phrases are located nearer the base position of your fingers." So I think it's a really interesting layout. I've started using it and I think it's worth giving it a try. Thanks so much. Those are my sources. Any questions?
Is Roland Kaufman related to Rob and Chelsea Kaufman? Just kidding. No, he has 2 N's at the end of his last name.
I don't know if Rob and Chelsea are from Norway, which is where that programmer is from. So he's not even a native English speaker who designed and developed that. But I don't know, you'll have to ask them. Family tree time.
So Chantal, one of my questions is, would you then recommend, based off of Dvorak's initial tests that he did
Mhm.
back in whenever that was, I can't remember at this present moment.
Mhm.
Was it anyway. What would you say that if someone wanted to switch over to this, that they just need to take like a long weekend of 18 hours of typing practice and then they will start to build that muscle memory? Or do you think that's something that, because we have such ingrained habits with the QWERTY system, that we would need to have more additional untruths? So now that we know one version, how much longer would it take to learn this new version, do you think?
Sure. So I think one of the things that needs to be taken into account, those studies were done in 1932, or around about there. And that was all done on typewriters. So technology has widened its scope exponentially since that time. The QWERTY keyboard layout isn't just on our computers, it's on our phones, it's on other people's computers. So switching over to Dvorak, if you're doing it on your personal computer, I've seen recommendations that if you're interested in switching, switch in one place. So if you have a work computer and then like a home computer, do it just on your home computer to start building up that muscle memory. A lot of people have found that they're able to train their brains to use both and still keep that in their minds. And I think that separation of learning environment helps with that. But I do think it would take longer. That 18 hours was for brand new typists to learn Dvorak. To spin off of your question a little bit, does that mean we should teach kids Dvorak? There's debate about that, and most of it lines on the side of no, because QWERTY is so ubiquitous. It would be a little bit of a disservice to train someone in something that isn't widely accepted and used. So it's more something that as an interested adult who knows how to do some typing or wants to improve or try something new or lessen hand pain, that's something that would make it worth giving it a shot.
I have a follow-up question. Did you run into anything in your research that talked about a flat keyboard system like what is used on most laptops, or kind of like the external, or a raised keyboard that is more designed similar to a typewriter for more ergonomic? Did you find anything with like the different types of physical keyboards that you can use?
Yeah, if you have a Mac, there are keyboard covers, like those rubber covers that you can buy. They're like $25, and that will like remap the surface of your keys to be mapped to Dvorak. That isn't necessary, and really with touch typing, seeing the keys isn't necessary. For ergonomics, the hardcore Dvorak evangelists love their ergonomic keyboard setups. So those are the ones that actually like are angled in a curve, so your hands are resting more like this, which is more natural than the front way. So that's really popular with a lot of Dvorak users, just to up that ergonomics factor. But even that switching to your home row is 70% of your typing does a lot of wonders for movement. One of the other factors with ergonomics is if you are having hand pain and trying to help adjust to that with ergonomics, switching to Dvorak naturally slows you down in that learning process, and slowing down helps that healing process. So as you're healing and learning this new method that's better for your hands, you're able to then build up your speed in a way that your hands are also healing. Any other questions?
Has anyone tried to improve upon the Dvorak keyboard since, and is there any success in that, or is it just like the end all be all?
Well, a lot of people will say that Dvorak didn't improve the keyboard, which I disagree with. I think it is an improvement, even though I don't think QWERTY's going anywhere. Colmark is another keyboard layout that has hardcore evangelists that people do think is another improvement. Maybe not from Dvorak, but is an improvement from QWERTY, and then there'll be, fights about which one is the better improvement. But that's hard to say. And as technology is advancing, there's more and more research into what actually is the best way for us to be working, because we're not limited to typing on keys anymore. Your talk with augmented reality plays into that. There's other ways that information input is being adjusted, and I didn't go into any research on that, but that is something where who knows how long us typing on a keyboard and that layout is going to be ubiquitous anymore. Time will tell. Any other questions?
I think that's interesting because programmers tend to like people who use Vim tend to remap their keyboard anyway and like have things available like closer to where their fingers lie in order to like toggle between typing and navigating and all that. I think that's really cool. Let's take a break. We'll come back at 10:30 with Jeremy. See y'all shortly.
Great work, Chantel.
Good work, Chantel. That was great.
All right, welcome back, everybody. Jeremy, I will hand it over to you. Great shirt.
Cannot wait. Oh yeah, I changed from a black shirt to a black polo. Great transformation on my part. All right, can you guys see a black screen?
We do.
Cool, that's my presentation. Thanks for coming. All right. Redux for Dummies, myself included. Before this week, I heard the term Redux thrown around a little, but never bothered learning what it was. So if you're like me, you didn't either, or you're just now learning about it, or you're an instructor and you don't care. Being ignorant and ambitious, I jumped right into Redux coding tutorial videos and spent a few hours confused trying to understand all this new boilerplate code. Not until I stepped back and looked at it all very high level did it start to click. So to help you not make my mistake, I present to you a codeless introduction to Redux with the hope that by the end you can connect the pieces to the actual code later on. Some things I'll be going over: what is Redux, when to use Redux, and when not to use Redux, the basic building blocks of Redux, and how all those pieces work together. So what the F is Redux? Redux is an open source JavaScript library for managing application state. Redux ensures that each component of your application can have direct access to state without having to send props to a child component or using callback functions to send data back to a parent. And Redux isn't actually React specific. So while it was written with React in mind, it can be used with frameworks like Angular and Vue. And spoiler alert, not everything needs Redux. For simple applications where UI doesn't rely heavily on pulling data from the server, or maybe you need to create a quick MVP, or simply you're just uncomfortable or new to React, Redux will likely be a waste of time. And props will do just fine. In short, there's a lot of boilerplate code to accomplish a simple function, and when you don't have much time, then you don't have time for that. Where Redux does come and save the day is when applications become more complex and have multiple components that need to access data or change data. Companies like Uber and Twitter use it, and so let's all be just like them. Here's a diagram, and I have many more to come, so just stay tuned. So this is a representation of a normal React app with different components with their respective child components. In this example, I am working on an e-commerce site. In the middle, as you can see, is my search results page that I've set to fetch and keep state of those search results. Then within its child component of a single search result, I initiate change by adding the result to my shopping cart. Say, what happens when I need to pass that data to my header or to my shopping cart that also need to display that state? Or if I change state in one of those components, how then do I change it in the others? One solution could be that you put the data in the app, but as you can see, things get quite messy really quickly. And the more passing of data from one component to another and vice versa are more opportunities for your data to get lost or accidentally changed. Instead, we keep state within, instead of keeping state within several different components, Redux keeps it all in one cool and safe place outside the mess. And if one component needs the data or needs to change it, it just needs to ask nicely to do it. So in this diagram, the orange circle represents a component without Redux that changes state and attempts to pass data to other components that need it. As you can see, the errors are all over the place, AKA not very good practice. With Redux, that same component can instead change state by dispatching an action to something called the store, which holds all state. And then once state has changed in the store, all components that need to see that change can subscribe to the new state. So Redux has three main building blocks that you should know about: actions, reducers, and the store I just mentioned. In this diagram, it shows that the line between the UI and the store have a couple more stops in between. So you can see that the UI will actually trigger something called actions. Actions will then tell the reducer what functions to execute in order to change state. Then once state has been updated, the store holds that new state. And then the UI pieces that need to pull that data can pull that data from the store. So backing up a bit, actions are simply events that are created using functions that send data from the application to the store. They are objects that hold two properties, the first being type, which just describes a type of action. So for example, if my desired action was to add 1 to a counter, I'd call it increment, for example. Or if I wanted to update a user, I'd call it update user. And mind you, these are just names that shows this is an actual static syntax. The second is payload, which is the actual data being sent to the store. So for example, it could be the object username, Jeremy, if I wanted to update user. And lastly, in order to call an action anywhere in your app, you would need to deploy something called dispatch, which is essentially a way for that action to then tell the reducer, which is next, hey, do this. So a reducer, on the other hand, are functions that take in both the current state of the application and the dispatch action as arguments, then returns a new state. Here, it's worth noting that reducers should be written as pure functions. So some key characteristics of pure functions are that they do not make calls to the database. As you know, external data is subject to change outside the function, as well as global variables, which are also subject to change elsewhere. And basically the return value of that function is dependent solely on the values that are passed in. So in this case, it would be the current state and what action is to happen. And then once the reducer has updated state, the store holds the new state along with the entire state of the application. Thus, different components of the application can then subscribe to specific state updates and display them on their UI. Thus fulfilling the happy circle of Redux. So hopefully you have somewhat of a top level understanding of Redux. So I encourage you to take some next steps in learning more concepts on your own, just because obviously there's enough time. But the first being functional programming. In short, Redux was built on functional programming. So understanding those concepts will give you insight on how Redux operates. Installation. Installing Redux is as simple as an npm install or a yarn add, and I'll provide that link in the next slide. And lastly, the syntax and methods themselves, which I clearly did not go over. I'll take some time. It will take some time to understand all the boilerplate, but fortunately there isn't anything glaringly different than the JavaScript or the React we already know. So here are some resources that help me and will help you. In particular, the Getting Started with Redux resource is actually a tutorial by Dan Abramov, who created Redux. He also created hooks, so you can either thank him for that or, I don't know, throw stones at your screen, depending how you feel. But like with hooks, it's all opt-in. And to quote Dan directly, if you feel pressure to do things the Redux way, it may be a sign that you and your teammates are taking it too seriously. It's just one of the tools in your toolbox, and experiment gone wild. Yeah, do you guys have any questions?
Jeremy, what project were you building when you were like playing around with this?
I'll back up. The project that could have been very helpful using Redux would have been the Trail app we were using. When we were trying to solve some better ways to refactor state, Alyssa brought up Redux, and I said, I've always heard that word, but what is it exactly? And then that's when she told me that it was basically global state. And basically the first time I ever understood what Redux was. And then looking into Redux and how every component can then access state without passing props or passing it back up seemed like the optimal solution if I could basically refactor our capstone project. But like I said, if you're uncomfortable with React or it's just like a quick project, then this is clearly a waste of time. But if you're gonna work for a company with a fairly complex app, I think more than 50% chance they are gonna use Redux or an alternative. And it's something worth knowing before going into a job or a job interview.
Jeremy, when you were first researching Redux, one thing that you talked about, which I thought was interesting, was you spent hours and hours jumping into tutorials and getting lost versus stepping back. What lessons did you feel like you learned during your research that you would apply to not just Redux, but other technologies as well?
Well, the first thing was that I was ignorant, and I entered it thinking, oh, it's related to React, because I heard the term React Redux, and I thought, oh, I think I'm good at React, so I'll just jump right into tutorials. So I guess my ego was like, I have a limited amount of time, so I'm just going to jump into these coding tutorials. And then obviously an hour or two in, I thought, I think I'm dumb. And then not until I found other resources that basically had the whole diagram description that I showed you guys, did it start to make sense, and did certain things I learned during tutorials start to make sense too. But yeah, I would encourage, before jumping into any deep topic like Redux that have multiple coding tutorials online, I would suggest you just understanding all the basic concepts. One thing I didn't go over, but I did mention, is functional programming, which is which is different than obviously object-oriented programming, but this is what Redux is based upon. If you understand how that works, then the concepts of Redux will make way more sense.
Cool, thanks.
Also, if you don't know who I am, here's my email. Yeah,
that's awesome. Jeremy, I was going to say, I also like your consistency of brand with using the same font from your portfolio site in your presentation. So
noted.
So now I want to rename it to like J. Gabriel font.
I use this a lot, I'm not gonna lie.
Cool. Nice work, Jeremy.
Thank you, guys.
Great job. Fantastic. All right. Thomas. Nice shirt as well.
Oh, okay. Can everyone hear me?
Yep.
Okay. So I have a learning environment for Q Learning on the right-hand side. I'm going to run it in some points, but I'm just going to be going through the slides. So hello, everyone. My name is Thomas Gonda. As for why I chose this topic, I'm pretty sure everyone is interested in machine learning. It's such a cool idea. But as to why I've narrowed it down even further to Q Learning, it's because I feel like Q Learning is the closest to how we actually learn as people rather than how a machine would do it. So what is it? An agent within an environment will make new decisions in that environment based on whether you give them a reward or a punishment for a specific action. It's used in industrial automation, data processing, aircraft control, and business, among other things. So the basic principle for how it works is, oh, actually first, let me draw your attention to this program on the right. So the way I'm going to test this is I have a maze, and you start in the top left, and the goal is to reach the square in the bottom right. If you touch the red square, that's considered very bad. And if you touch a neutral square, it's considered a sort of slightly negative punishment. The agent is rewarded for good behavior and punished for naughty behavior. The reason why every neutral move is considered slightly bad is because otherwise you can have, let's say, a board like this. It's just a 1x5 grid. Start, empty space, empty space, empty space, end. Right, right, right would be valued the same as right, left, right, 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 even though the direct path is more valuable. But if we give every move a slightly negative value, then it starts to value quickness as well as the best path to the end. So while I'm explaining how reward is calculated, let me actually run the program. So you can see the agent in the game taking a bunch of random paths at first. And if it touches the red square, the green square, it will end that iteration. So the reward for how it's calculated looks a little complicated, but once you break it down, it's really not so bad. So you can see the line in my program where the state is actually updated right here. This QSTAT means it's a function for value. And the ST is the current state, and the AT is the action you take while at that state. So that gets updated by this equation over here on the right. So you can see this learning rate, or this alpha. If it's 0, then obviously everything on the right won't be activated at all. So a value closer to 0 means it values the old information more highly. Value closer to 1 means it values the new information more highly. This discount factor is a value closer to 0 tells it to value only short-term rewards. Value closer to 1 is long-term goals. So let's say you're like running through the woods, or let's say you're like on Google Maps and the birds like flight to the destination. If you start in that direction as opposed to taking like roads there, you might get there like a slight short-term reward more quickly because you're going directly in the direction of your destination. But it's actually not really the fastest path because taking a road will make you like go at a quicker speed later. So that's why the discount factor is important. And this temporal distance basically means adjusting the values of the model like mid-calculation, like mid-iterations. So you don't just look at the original values of the model. You actually, it gets updated after every iteration. And this, this part right here, this max Q and old value is the expected best possible result from your new square and the state that you're currently at. So that's how reward is calculated. So let's take a look at the values this generated. The value at each square is how good it thinks to be at that square. So you can see it thinks being at a square in the bottom right is very good, and being at a square in the top left is very bad. And you can also see a sort of slight preference for the bottom left as opposed to the top right, even though both of these paths are the identical distance. This is because sometimes when the program goes top right, it accidentally falls into this hole, which it considers to be a very bad thing to happen. So you can see this reward is -1. Yeah, so it slightly prefers the bottom left, even though the distance should be exactly the same. So you can see it can also take into account safety as well as distance. So why don't we check out the results? So I ran it for 50 iterations, but ideally if I ran it for 500, it should be even more accurate. So it matches up kind of the same. The values in the bottom left are better than the top right. and you can get a recommended move based off of the values that you generated. Basically, on each square, it looks on the squares next to it, and the square that has the higher value, it will move into that one. So let's say you're in the top left, it thinks going down is the best decision because that has a higher score than the square to the right of it. So every square, it gives you a direction that it thinks that the best move at that position is. So I said at the beginning, Q-learning was the closest machine learning algorithm I could find to the way we think because we have rewards and incentives. So let me talk about a few other ones because I was doing research on this and I found some of these and they're really fascinating as well. So NEAT generates many agents as opposed to one agent. And it picks the agents that closely have the behavior that has the characteristics that we most want. And then it breeds those onto the next generation instead of having a single agent to it. And Monte Carlo is pretty sure everyone's heard of it. It's like similar to Q-learning, but it does not update its model after it completes an iteration. So if you run Monte Carlo enough, it should give you a similar result to Q-learning, but it usually takes longer because it's not updating the incentive after each iteration, but it should get there eventually. So Q-learning is like a more advanced version of it, really. And value iteration is another machine learning method, but it can't be used in all cases because it requires more information than you usually have. It requires information about the incentive for the transition as opposed to the actual state itself. So, okay, I'm almost done. The resources that I have. So the reason why I was so inspired for machine learning, I mean, everyone thinks it's cool, but once upon a time I was looking on YouTube and there's like a bunch of video series for like how video games can be beaten by AI. And so this is one of them. It's like how a Mario level can be beaten by a machine learning a program just like this. So there's a bunch of series like this, like AI learns to play Flappy Bird, among other things. I think it would be super cool for you guys to check that out. Yeah, and here's a bunch of papers that I looked at for the equations and stuff. All right, is there any questions?
Hey, Thomas, do they use this when they create games because of the algorithms and being able to add the values and the rewards?
I don't think so. I mean, when you create games, you're creating like a static environment, you know, ahead of time. Maybe when you're like programming the AI for like enemies, but as opposed to creating the environment itself, I don't think you would use this.
Did you spin up the like this learning environment yourself, or is this like a source that you're using? It looks like you're using Bluehost 3000, so I'm guessing you made it.
I made like 20% of this. I took someone else's code and I made some alterations for Q-learning to work. It was like this was originally like a Monte Carlo, but I changed it for Q-learning.
Cool.
The equation that they used to search through the maze. No, this still took a long time.
I bet. What like can we see your code? If you have it available, I'm just curious.
Sure, this is the how Q-learning is calculated right here. I took this line right here. There's a bit more to it than that. Yeah, I'm really there's a lot.
Yeah.
Yeah, but it keeps running iterations based on how much data you feed it, and then the value at each square gets updated after each state transition. That's basically what it's doing, and that value is based on that equation that you saw.
Would it be possible to build this where there's overlap, where say you're starting in that upper left-hand corner, if it moved to the left, it would then show up in the upper right-hand corner?
You mean like wrap around?
Yeah.
Oh, I mean, that's basically what the game Pac-Man does, right?
Right.
You walk through one wall and you come out the other one. They have done like Q learning for that game as well, which is really cool to see. So yeah, you can.
Very cool.
Thomas, what prevents the AI from realizing? I'm assuming that the pathways are initially set up, but what prevents the AI from saying, well, I could just jump from the top of the left into the green box on my own? Like, would it ever get to that point? Or is it because the pathways are so, like the function that you're telling it to do, it would never say, well, I'm just going to skip all that and go through the wall or something like that?
Oh, well, okay. So the agent has always 4 moves. It has so the agent has an output that you receive. It's the state and it's the state, and then it's taking an action. And the actions that can take are up, left, right, and down. It can't take an action that's not one of those 4 things. So it won't be able to like beat the game.
Cool. That's awesome. Have you ever run up against like an AI version? I'm assuming that you play against AI for chess sometimes. Have you ever run into that to get better, or could a video game designer basically build an unbeatable game?
Could a game designer make an unbeatable game? Absolutely. Chess has been conquered by computers. There's not really any point in trying to play one. It's better to play against other humans than it is computers. But yes, you can make an unbeatable AI in chess with this.
Nice. That's cool.
Have you watched the documentary, the AlphaGo versus
I have. It's
East?
very fascinating.
Yeah, I loved it. Just wanted to share.
The human won a game, which is very cool.
Cool. Thanks, Thomas.
Thank you.
Nice job. Very cool. Great, Ruben.
Hi everyone, I'm Ruben Ramirez, otherwise known as Rubes. Have any of you ever wanted to kind of hack or program electronics? Well, and been too intimidated to kind of start, because you think, oh man, that probably takes like a really low level language, probably really hard to learn. Well, no worries, because I'm going to introduce you to the Arduino. Oops. Ta-da. All right, what is Arduino? Arduino is an open source platform based on easy to use hardware and software. It consists of a microcontroller and the Arduino IDE, which is also known as Integrated Development Environment. So now you're probably asking yourself, what's a microcontroller? Is it just a really tiny controller? Nope. It is something that's found all over the place. It's found in most appliances. It's found thermostats, remote controls for TVs, pretty much everywhere. And it's a circuit board with a chip on it, and it can be programmed to do many things. And to read information, they use sensors. So an example would be like an infrared sensor, a motion detection sensor. And it takes that information, and whatever code you wrote for it, it runs it in the chip, or in the microcontroller, and using an actuator, that's what it does in action. So an actuator would be like a power switcher. So depending on what you wrote in the code, It can display or store data. All right, so now about the Arduino software. Let's see. The Arduino IDE includes a text editor, a compiler, and a debugger. It allows you to write instructions for the board, and most of the instructions, the Arduino programming language is really just made up of a bunch of C and C++ functions. They're kind of already made for you to use. And yeah, so now you're probably thinking, oh man, C language? Ugh, that sounds hard. Well, no need to fear, because there are also other languages that you can use and other libraries that allow you to use stuff like JavaScript. So a really cool JavaScript library is Johnny5, so you can control the Arduino with it, and you can just control it with JavaScript. You can make robotics, you can turn on LEDs, you can hack other electronics. So right there at the bottom is a little snippet of just turning on one LED with JavaScript. Really cool. So what can you build? There's a lot of different things you can build, but an example is you can add an infrared sensor to the Arduino that reads the light from the remote. So whenever you turn on or press play, and you want to watch a movie, it'll read the sensor that you pressed play, and it'll send it to the Arduino, and it'll read whatever code you wrote, logic for that, and it'll send the electrical signal to the power switcher, which will turn off the light. And to summarize, yeah, Arduino is great for beginners, and it consists of a microcontroller and software that are both open source. And open source meaning it can be freely redistributed or modified. The hardware and the software are both open source. So, and there's a lot of great libraries such as Johnny5 that allows you to use JavaScript, since I know a lot of you use JavaScript. It's a really cool thing to use, and lots of things to build. Some resources to get started is the Arduino website and the Johnny5 documentation. There's also a really cool streamer called Nukecat. She streams every Sunday, and she's always like using JavaScript and hacking hardware. Really interesting. Cool. So thanks, everybody. You can find me at rramirez216 at GitHub. And any questions?
Have you built anything with an Arduino yet?
No, my Amazon Prime wasn't fast enough. I've always been interested in it, but like only recently I kind of like discovered Johnny5. I'm like, damn, it sounds really cool. I want to code hardware in JavaScript because I love electronics, and I just finally kind of jumped the gun and decided to maybe learn it, do it on the side.
What's the first project you're gonna make?
Ah, man, I don't know. I really want to work with like lights. I don't know, something with LEDs or a display. Not entirely sure. I'm still looking. Is that it? All right.
So Ruben, what is the cost of one of these microcontrollers, and do you have to have a unique microcontroller for each appliance or whatever that you're going to try to hack, or can you use one for multiple different things?
You can use one for multiple different things. Another cool microcontroller is a Raspberry Pi. Yeah, both Arduino and Raspberry Pi, for a basic board, it runs like $20 to $30, maybe a little bit more. But then you also need a lot of other things like the sensors, actuators, a bunch of other electrical, a breadboard to put the pins in, and so it might spike up a bit to maybe 50, or 70 starter kits, but yeah. And yeah, most of them you can use on pretty much any electronic. You just need kind of the little side things that connect to those electronics. Yeah.
What's the difference between a Raspberry Pi and an Arduino?
Not much of a difference. Probably just the software that they run, but they're pretty similar. Both Raspberry Pi and Arduino have different types of boards too. Some are smaller, some are bigger, more powerful. So, but they're really similar. Both you can do the same thing. Johnny 5 also works with Raspberry Pi too, not only Arduino. So yeah, hope that answered that.
What does Johnny 5 reference?
Don't remember. I think it has something to do with the robot that's has its hand up like that. I remember like I did skim through that quickly of what Johnny 5 meant, but I know it has something to do with that robot that's on their front page.
Johnny 5 is a very famous robot from the 1980s short circuit film series.
Well, there we go.
Yeah.
All right. Any more questions?
Nice work, Ruben.
All right, sweet, thanks.
Great job. All right, Chrissy.
Hello. Let me get this set up.
And nice shirt as well.
Yeah, I changed. I thought a muscle tee wasn't appropriate attire, so I went lumberjack for this one. All right, so let's get started. My name is Chrissy Akau, and I'm doing my tech talk today on Moment.js. And let's kick it off with a little quote for you. All right. Time is what we want most, but what we use worst, William Penn. And that's some Quaker knowledge from the founder of Philadelphia for you. And, you know, time is an invisible force and foe to humans. You know, we often wish we had more of it, feel like it was running out, felt like time flies, like we're already in our third month of Learn, which is pretty crazy. And it's illustrated brilliantly in Back to the Future and The Lake House, both classics. And these both show kind of the innate want of humans to be able to control and manipulate time. Time, however, as Rob pointed out in one of our lectures, is something that as humans we are terrible at gauging, controlling, and manipulating. And another thing that is also bad at that is JavaScript. As I think a lot of us discovered during our capstone projects, the date timestamp is not aesthetically pleasing and kind of a pain to deal with. So Moment.js is here to simplify that for you. And if you do not use Moment.js, you have to do a lot of complicated parsing and methods, and it can get really complicated depending on what you want to use it for. So Moment.js is here to help us control some time. So let's do that together. So what is Moment.js? Moment.js is a JavaScript library, free, open source. I think you've heard other people talk about some JavaScript libraries, but basically it contains a bunch of functions, and those functions accomplish a task for your app or web page. A JavaScript library you're all probably familiar with is jQuery. And the function that we'll be getting from the Moment.js library is the moment function. Go figure. And basically it helps parse, manipulate, format, and display dates and times in JavaScript. And it's essentially a wrapper for the date object. And as we all know, I think, Charlie, you guys have already covered objects. They are the bread and butter of data manipulation. So it makes it very easy to work with. How do you get Moment.js? Excellent question. So Moment.js.com has excellent documentation. So again, many resources online as well in Stack Overflow, etc. How do you use it in a project? So there's two ways. First, you can download it, and it's not even really a download. You click it, and then it pops up onto another tab, and it's a minified version, JS, and so you just have to copy and paste it into a JS document. There's two different versions, which I'll get to the moment with locales when I show some coding. The other option is something probably we're all familiar with, the good old install in the terminal. So you can use it using a yarn install, yarn add moment. So that's how you would get it. All right, so we're gonna do some coding examples. So Moment is kind of neat because I was gonna do pictures of it, but it actually updates live. So I thought it'd be cooler to do it live. So I think you guys can probably see my editor, and then I have an HTML document. So the way I implemented moments in this was by doing the minified JS version. So I made a JS document, copy and pasted that, and then have it right here referred to in the source, and it works. So that's great. So for this first example, we're just going to console log moment, the moment function. And just a heads up, the moment function itself is always going to be your current local time, always. So if you're somewhere else, it'll be that current local time, which is pretty cool. So this first example is right here. So let me go and refresh it. So it says 11:10:40 seconds, refresh, boom. It's updated with our current to the second, which is awesome. And then you can take a look here in the object and you can see some of the methods that you get with Moment.js. And this is only a few of them, but it's pretty cool and robust, which is awesome. And then for the second example, to get it as a string, so kind of a sleeker version without being in an object, you just use the .toString method. I created a variable called time and to contain the moment function. And as you can see here, here's a cooler, sleeker version. July 16th, we can refresh it again, and it'll show you it updated. Just like any other JavaScript method, there's a getSet method. So just to save time, I use the .get method. There's a .set method, pretty easy to remember. And it can get you the year. So the current year, again, the moment function is our current day, time, year. Is 2020. You can also do the quarter, so it should give us 3 if we're to do quarter. Here's the locale token. So I mentioned that Minify.js version that has with locale. That basically gives us the American English version. So this capital L indicates American English, which, as we all know, Americans like to do everything different than the rest of the world. So the format you would get is the month, day, year. Everyone else does it the other way around, which kind of makes more sense, but whatever. We're American. And then some cool formatting things that Moment.js also does. You can put .format is the method you call in it, but you can put words inside brackets, square brackets, and it'll read that as text. And then if you use tokens, which if you look at the documentation on Moment.js, it'll refer to those. So like 4 lowercase d's equals the day. And then the year, the capital Y's, would be the year. So I have over here logged, today is Thursday, and the year is 2020, aka the year of the apocalypse. So that's pretty neat if you wanted to do a customized format for a website or app. Another cool method is the .calendar method, and it's kind of like a cute little way to, actually, let me update this. It's actually a cute little way to also display the time. So instead of being like super businessy with the actual date and numbers, you can say like today at 12:13 p.m. And if you were to do one day using the add method over here, it would say tomorrow. Once you get past 15, it does the digits again. But so those are some cool methods that I enjoyed when I was going through this. And then just like anything wonderful and great, Moment.js comes with a few problems. So big issue with Moment.js is it's mutable. I don't know if you guys have gotten to Ruby yet, but basically mutable means, so let's say if I wanted to create a variable that had a date, August 16th, 2020, and I was like, okay, cool, I'm gonna do another variable, and I wanna add a year to it, but oh, hey, I want a console capture, so hopefully it would give me 8/16. And then below, we kind of did the same thing, but with a day. And unfortunately, if you're to do this, you get 8/16/2021 and 8/17/2020 when you console log the variables because it's using the same object. And that can cause confusion and a lot of bugs on your code if you don't realize that Moment.js is mutable. And there's a few solutions for this. So the first is you can pass Moment.js objects as an argument to Moment, which creates a new instance. And you can also use the .clone method, which clones that variable. And then, as you can see here, it is not mutated. So 8/16/2020, 8/16/2021, and then also with the days, 8/16, 8/17. So that's pretty cool. A couple other issues with Moment.js. Some people say it's a little slow, depending on what methods you use compared to other libraries. It also is, like I said, very robust, so it's kind of heavy, and it doesn't support tree shaking, which helps reduce the size of files. And I think a lot of us ran into this issue with Heroku because some of that Webpacker adds a lot of unnecessary bloat to it, so that's something to consider. There are alternatives to Moment.js. There's Day.js, Luxon, JS Yoda, and Date.fns, but of course, all of those also come with some pros and cons, as is life. So some great pros of Moment.js. There's a large user base, so bugs get fixed regularly, and there's lots of resources if you run into issues. There's lots of really cool external libraries that have various functionalities. So there's a really cool one called Moment Business Days, which allows you to work only with business days, which is cool if you did like a business app. It also works in the browser and Node.js environments, so it works front and back end as well and has a really great API. And it supports internationalization and localization. So front end doesn't need to provide support for additional translations for languages that are already implemented in the app, which is pretty cool. And yeah, thanks for controlling time with me today here with Moment.js. Good old Thanos, that's me on my good days. And let's see, here's some resources for you. So a few buzzwords that were really confusing when I was going through this is UTC and GMT, which you guys, if you want to ask me about it, but it's different ways to tell the time. And some Moment.js resources, as well as a really good YouTube tutorial. And there's my face. Cool. Awesome. So that is Moment.js. Does anyone have any questions?
So what is the GTM and or GMT?
Okay, so it's so there's UTC, which is Universal Coordinated Time Code, and then GMT. So basically, there's Greenwich as like the 0 meridian, and so if everything from there, if you go to my code, you can see that there's a GMT offset. So basically, Pacific time is 7 hours behind that UTC time code. If you're in Australia, I believe it's 10 hours ahead. Mountain time would be -6. So it's something to keep in mind as well. And it's really annoying because we have daylight savings time, so that changes. So sometimes you have to be aware of that as well. So it's just how many hours are from it. If you're to do from UTC, it would just be 0. So.
Did you find a favorite Moment.js method?
I really liked calendar. I thought it was really cute. It was like I like a cool way to display the time without being too formal, which I think is really cool and applicable to a lot of things. But yeah, there's a lot of really neat things. I also like that you could customize it with the brackets. I thought that was really cool. Those are 2 things that stuck out to me for sure.
Chrissy, would Moment.js help support if you were to be building like a form on an application to sign up for an appointment time? Could you use Moment.js for some of that formatting and those types of things, or is this more for that the timestamp on the application and those things?
That's a good question. I think I would like. Looking back, I wish we used this in our Trails app because the date time, like we had to do .substring to get rid of the time. So I would say it's probably most useful for like comments, questions, or like just dates of actual posts, as well as like a greeting, I think would be something that you could do because you could probably manipulate that to be updated as well. So
cool. Awkward silence.
Yay!
Nice work, Chrissy.
I love awkward silence. Thank you, family.
Me too. I now have to go back and think about how I teach Tech Talks because I'm laughing at all of you going, "Hello, I am."
Yeah,
first name, last name.
I was gonna do like a dramatic entrance with the headphone, like, "Hello, I'm Chrissy, and this is my TED Talk." You know how they do with the headphones, but I didn't because time.
Awesome.
I love it. Nice job. That was great. Jasmine.
Yay. Can you hear me? I hope so. Okay. Yep. I do have to say though, everyone has been like amazing talks. Awesome. But I just had to say that before I started. So, like Sarah said, my name's Jasmine, and my Tech Talk today is going to be specifically on an API and what is an API. It's going to be super, super high level, super, super basic, because that's the only understanding that I have as of now. So, Since I decided to become a web developer and join Learn, I found that this term API was said like all the time. The necessity of understanding what it actually is and how it functions as I kept going was like becoming more and more important as I was going through my journey. And so by being inside this new industry, I figured out that obviously the necessity of understanding what an API is and how it functions was going to be highly important. So thus my curiosity and needing to understand the term API or application programming interface became. So the definition. An API is a computing interface which defines interactions between multiple software intermediaries. When I first read that, I gave that same face. So let's give a definition that I actually understand. An API is the messenger that takes requests and tells a system what you, the user, wants to do, and then returns the response back to you, the user. So that definition made more sense to me, but if you are a visual learner just like me, you're going to give this face now. So let's go ahead and illustrate this into a term that you will actually understand. Imagine you're at a restaurant. I know foreign idea for today, but imagine being in a restaurant during the good old days. You are figuring out what you'd want to eat by looking at a menu. How are you going to translate to the kitchen what you'd want to eat or drink? Do you get up and actually go to the kitchen and order to the chef that's making food for dozens of other people? No, that's ridiculous. You need a waiter, in this case, the messenger. You place your order to the waiter based off of the options given to you through the menu. Then the waiter translates it to the kitchen. From there, the waiter brings you your food. Now that's a great scenario and stuff. Made me wish to go back to being able to hang out in a restaurant without the fear of getting a crazy killer disease. But there's a purpose to it. In this scenario, the menu is your options, or the interface you're working with. The kitchen is the system. And the waiter is the messenger, or to be more specific, the API. Doesn't the idea of an API seem a little bit more simple? Well, let's look at some examples of an API in use today. Bunch of examples, specifically based in travel, because that's the easiest way for those who are beginning to learn what an API is to understand. Searching for flights, just like at a restaurant, you have a menu of options to choose from. You have the city you're going to, what type of seat you'd like, price range, etc. Tons of other examples. In order to book your flight, you may go to the actual airline's personal website. In this scenario, no actual API is needed to look at flight information since we're in the actual airline's website. There is a direct connection with the airline's database for the needed information. But if you're in these examples, Hopper, Priceline, Google Flights, etc., then you need an API in order to get their information for the type of flight that you want. The API in this case is going to take the information given to it by the interface, or Priceline, Google, etc., send it off to all the airline systems. So, for example, Delta, JetBlue, etc. Then it gathers the information that was asked for it to receive and sends it back to the interface for you, the user, to see. These are just one of many API examples that we use often today. So, to the point, an API in its basic form is: 1, it receives information from an interface. 2, sends that information to one or more than one system, and then sends back the information requested back to the interface for the user to see. So that's what an API is at a high basic level form for everyone to understand. Questions, please be nice.
Did doing this research help you understand more of the projects that we did when we were building a backend as an API?
100,000%. I was actually in a lecture, and the whole entire time I was hearing API and everything, I had no idea what was going on. But now when I think of an API, I just think of it being as a messenger between two systems, and then it made perfect sense.
Jasmine, what made you think, why did you connect it to a real world example, I guess is my question.
In order for me to understand really high complex topics, I have to bring it to something I already know really well. And everyone, and including myself, knows how a restaurant functions. My dad is in the restaurant industry, and so that was an easy understanding for me to understand what an API was. And then once I had that basic understanding, I could bring it to yet another example of what specifically an API was that I use all the time.
Awesome. Thank you.
I feel like one of the confusing things about APIs is the idea that they sort of exist in the wild, like your examples with the flights, but also that as a developer, you create your own API. Did building this out like help you connect the dots between all of the APIs that you've dealt with through the class?
Yeah, it helped me. I actually went through back my community kitchen, my capstone project from my group, and I looked at what I specifically didn't work with that API, but I'm going to have to work with an API in my internship. And so going back through how that was done made more sense.
I have a question about APIs that I don't understand. Do APIs mainly, or do they only use JSON?
I actually don't know the answer to that question. From my own brain, I would assume, I don't know. I don't want to give you a wrong answer.
If the developer was nice, they put it into JSON for you.
Okay. There's real awkward silence. I think everyone's done. Okay, good.
Nice work, Jasmine. I love awkward silences.
That was fantastic.
Did you all know that every time there's an awkward silence, someone in the room is thinking about Abe Lincoln? Did you know that? Do you know why that will happen? It's because I just told you. So the next time there's an awkward silence, you will be the person who's thinking of Abe Lincoln. You're welcome. That's my tech TED Talk.
Brain hacker.
Brain hacker.
On that note, April.
Hi, everybody. Can everybody see my screen okay? Perfect.
Yeah.
All right. So hi, everybody. My name's April Rieger, and my tech talk for today is about styling Ruby Devise login forms for a React and Rails application. So when we create a React and Rails application with the addition of Devise to help us authenticate users, Devise automatically installs some generic views for us. In this tech talk, I'm specifically going to be referring to the login form, but you'll be able to apply this knowledge to any Ruby forms. So you can see on the right here, there's a login form. It's very basic and general. This is the generic view that Devise gives us. Devise provided a way for developers to style these forms by allowing us to generate our own and override the defaults by one terminal command. Rails generate Devise :views. So this one command will build out an entire folder of forms, as you can see down below. This the login form, which is the new.html.erb file within the sessions folder. And then if you look up above it in the registrations folder, you'll see a new.html.erb file, which is our sign up form. And you'll also see the edit.html.erb file, which is the forgot password form. So after we generate the Devise views, you can see the basic boilerplate code that includes a header, a couple of form labels and fields, a remember me checkbox, a submit button, and a couple of links that will route our users to the sign up view or forgot password view. And you know, this is a really bland form already, so we're gonna take it and give it some styles. Now, if you've used React Strap in your components with your forms and inside of your components, and you need to mimic that layout, you can use the Bootstrap version of those components in your Ruby forms. On the left, you'll see a Bootstrap form, and on the right, you'll see the React Strap version. And you can see the similarities in the structure of the layout and can use those classes in your layout structure to ensure a consistent design. Now, these areas that I've highlighted here are going to contain your Ruby code for the forms, but I wanted to point out the classes associated with the specific form fields because we're going to see these again. Okay, so now if you just can't get your form styled in the exact way that you want, even with doing the Bootstrap version of your React Strap component, you can inspect your page by right-clicking on it and selecting the Inspect from the menu. And then with our dev tools, we can take a look at the classes and the styles associated with each form field and carry those over into our Ruby form. And I just wanted to point out, there's that class again for our form control and the styles associated with it. A few things to note when you're styling your Ruby forms. One, you need to make sure that you link your style sheet into the head of your document. You can also encapsulate your form inside of a div and assign it a specific class to give you more control over your styling. You can also add inline styles. It's not the greatest thing, but you can have that functionality. And you can also give your form a specific class by adding this line of code. It's Ruby code from your form. And you'll notice that this is the same class that we saw when we inspected our React Strap form. Something that I wanted to create when I created this form is to take away the label and only have a placeholder. So you can see inside of the box, it'll just say like email or password, and it just alleviates the need to have actual label. So you can add this line of code in and it'll add the placeholder to it. One more thing I wanted to point out is that when you're trying to style your components or your bootstraps that are within either React Strap or Bootstrap, in order to override those styles, you're going to need to use the important rule within your CSS styling. And this is the styled form. So my capstone project with my team, we created this design and we were able to style it just like it was within the React components. And it has the same items. So it has a header, it has the email form field, but this time with a placeholder, and then the password form field with a placeholder, a remember me checkbox, a submit button, and a couple of links that will route the users to the sign up view or the forgot password view. And with one terminal command, it's kind of cool that it adds all of the forms, and then we can add new styles in our style sheet and have a really good looking and consistent with our branding form. Anybody have any questions?
So April, when you refer to the consistency in styling, if you were to have clicked on the sign up or clicked on forgot password, would those forms have identical styling?
They do not. You have to add that styling in, but once you do
okay.
one Ruby form, it's kind of easy to copy and paste over the classes and your structure. So
nice. That's awesome. Cool.
So can you go back to the example page?
Absolutely. This one?
Yeah.
Okay.
So I guess this is one of the big difficulties that I had was differentiating between the like .erb syntax and the HTML syntax. So that's the proper syntax to add a class to this, as opposed
for the actual form field, adding it this line of code here, which is within the Ruby. This is how you're able to just get that one form field, give it a class so that you can give it a style.
Got it. Okay.
What was the most helpful piece of documentation that you found, and like how did you find your way to that piece of documentation in the end? Because I feel like this is a place where lots of people can get lost.
Trial and error. When my team and I were doing this, I knew I was like, I don't like the way this form looks. I want it to be consistent across like everything. So I took the time to kind of like dive down that rabbit hole. I know I asked you a couple times, Alyssa, like, how do we do this? And you're like, you have to recreate everything in HTML. And I was like, no, that's not going to happen. And then I couldn't let it slide. So I did a lot of playing around. I looked at Bootstrap and React and looked at their documentation. I think I looked at a couple different tutorials, but nothing was conclusive. So it was really just playing around and messing with it. I know that I had done a couple of things wrong and linked the style sheet in the wrong format. And because of Rails magic, everything worked. But when we uploaded it to Heroku, the styles weren't picking up. Bootstrap wasn't in there. So like realizing you're having to put the import field in your style sheet for Bootstrap was kind of a big thing. But other than that, like everything else just kind of worked with a nice mesh between the HTML language and your Ruby language for the form.
This is super.
Any other questions?
So sorry, just to reiterate, like the import that you have here was the thing that you were struggling with when you went to deploy?
Yes.
Okay.
Yes, because I was putting it into the application, the SCSS file, and it wasn't picking up the style at all. So adding it to the top of the actual form allowed it to pick up those styles.
And so this import was on every form that you needed to style? Okay.
Yes.
That is good to know. That was awesome.
April, I was just going to comment really quickly that I think that this talk/topic in particular is a great example for everyone who's watching, but particularly for Charlie, how frustrating coding can be. And that it really does just require kind of, sometimes the documentation is not there and it's about logically working through and trying things out. So I just want to applaud you for working through this in particular, because I know that it's a big topic for even senior developers as well, and a lot of people. And it's the I don't want to say inability, but it's the not looking at two different documentations and seeing how they like cross together. So I think this is a really good example of looking at two different documentations and finding the solutions from things that aren't just documented for you, which is really great. So you should put this on Stack Overflow, just saying.
Well, I really wanted it to give to the Charlie class because I didn't want them to have like the same frustrations that I did or my team did. So yeah, awesome. Cool. And then I'll put this in, and I've got the resources tab of my team's capstone project links for our login form, as well as the GitHub repository, so you guys can kind of take a look and see what we did and how we got it to work. But yeah, thank you so much. I really appreciate you guys coming and seeing our tech talk.
Cool. Awesome.
Nice work. That was fantastic.
So kind of just what Sarah said, you guys are like really great job on Tech Talks. Charlie class, this is a really awesome example of Tech Talks. As you saw, a lot of them are were kept very simplified, which is a smart move rather than to overcomplicate. To use Thomas's as an example, I've seen people try to come in and do like an entire talk on machine learning versus really breaking it down into one component, which I thought he did really well. You saw that throughout a lot of the other presentations as well. So, and it's a really great opportunity to prep for internship. So a lot of the things that you guys saw here today were for Bravo's preparation to go into their internships next week, which I think are awesome. And we got to see some other really awesome things. So I'm very, very happy and proud of Bravo. So give yourselves a pat on the tush. Backsurfer, I don't know. I don't know. I need to stop talking. I've been up forever. I'm tired.